So regarding the powder mechanical powder production techniques, there are having different methods like mechanical methods. In mechanical force such as compressive force, shear, and or impact to facilitate particle size reduction of bulk modulus. So that is what the first thing. So in the mechanical method, we are having different types like milling, mechanism of milling, different abrasion method, chopping or cutting method, machining method. So these are the different methods are going to be considered. In case of milling, we are going to consider impact, adhesion, shear, and compression force. In case of the mechanisms, whatever is going to be considered, it is microforging, fracture, agglomeration, de-agglomeration. So regarding the impact, in case of impact, striking of one powder particle against the another is impact. Attrition is the production of wear debris due to the rubbing action between two particles. Shear, cutting of particle resulting in fracture. Compression, particle broken into fine particles. That is what squeezing. In case of microforging, particles are impacted repeatedly so that they are flattened with less change in mass. So that generally we are going to consider it as your type. So next regarding the working operation, in case of milling, the basic principle of milling is the application with respect to the application when a impact and a shear force between two materials. Generally, a hard and a soft material to be used, which is grounded into fine particles, and these milling techniques are generally used for brittle material. In general, most popular milling that we are going to come across with respect to the machining characters, and this machining characters, whatever we are going to consider, that will be taken care with respect to the working operations. So these are the different milling equipments that we are going to consider. That is crushers. So in crushers, we are having jaw crushers, gyrator crushers, rolling crushers. In case of grinders, we are having a different roller grinders. That is ball mill grinder. In case of ball mill, so this is our best example wherein with the help of this ball milling only, the most of the material or the powder that is going to be manufactured. Here, in case of ball mill, it consists of a cylinder vessel which rotates horizontally along the axis. The grinding media, which is made, whatever the grinding media is there, which is made out of hardened steel or a tungsten carbide, like ceramics, agitate, porcelain, alumina, zirconia. So these are the grinding medium. The next, this process grinds or powder material which is going to be impact with the adhesion, and the dry milling here, whatever the operation is going to be considered, we are going to mix both. The vessel is mixed with the charging medium. During the rolling between the vessel and the grinding medium, the powder particle roll over up to the certain height, and this process grinds the powder by impact or collision method. So for this, an easy example I'm going to take that as an, I think you had seen the coin, whatever we are going to use. So initially it will be pressed out. It will be a press is going to be taken, and the coins is going to be taken out. The end portions it has to be get trimmed or grinded out. So you cannot hold each and every coin to grind it. So that's why what they are going to do, they are going to use this ball mill. So in this ball mill, they are going to add the coins, and certain additives like grinders is going to be added out, and it will be continuously rotating. While rotating, there will be an operation, there will be an abrasion between the faces, and that abrasion is going to be is going to be run for a particular amount of time. Thus, in turn, gives the polish as well as the material end finishing is also has been given. So that is a best example that we are going to consider regarding the material polishing action. Especially this material polishing action, whatever we are going to see, will be taken out with respect to the ball mill process system. In case of ball mill process, the rotation of the drum, whatever we are going to use, that plays an important role, especially for doing the machining operation. If the rotation is not up to the required level, then automatically there will be an error in the milling operation. In case of dry milling operation, generally 25% volume 25 volume percentage of powder is added along with 1 percentage of water of a lubricant such as 1% weight of lubricants like stearic or oleic acids. In wet milling, powder is of 30 to 40%, and agent whatever that we are going to use, it may be water, alcohol, and hexane is going to be used. So the minimum diameter of the drum is it should be a minimum of 250 millimeter. Just imagine what is the minimum shape that is has to be required for grinding operation. Next here, one more type is that is vibratory ball. Here it takes a longer period, but whatever the powder that we are going to use, it is of a fine powder. It is having high amount of energy is going to be imparted, and the particles which are accelerated by vibrating the container. Here, a drum is lined with wear resistance material. 80% of the container is filled at starting with grinding and starting material. Frequency is 1500 to 3000 oscillations per minute. Amplitude is 2 to 3 millimeter. Amplitude of oscillation. Just imagine the height. Amplitude means the height. Grinding bodies are like steel carbide balls, which is having a minimum diameter balls having a diameter of minimum diameter of 10 to 20 millimeter. Fine particle size that we are going to get is up to from 5 to 100 microns. So in case of vibratory motion, it is obtained by an eccentric shaft that is mounted on a frame inside the mill. The rotation of the eccentric shaft causes the drum for vibrating in the oscillation. So this is what especially in case of grinding. In case of grinding, as you can see, so these three, that is the jaw crushers, gyratory crush, and cone crush, or the roll crush. You know, one more is cone crush, the other one is roll crush. So in case of all these operations, especially uh, the jaw crush plays an important performance with respect to the fixed and the moving one. Here, in case of jaw crush, the left hand one is moving and the right hand one is the fixed one. So that is regarding the applications that will be moved out. In case of gyrator, the circular rotation is going to be placed and it will be the material is going to be fed above it. The next one is roller crush. So here also the roller, both the rollers will be rotated in operating opposite direction. One is at the clockwise and the other one is at anti-clockwise. So regarding the requirement, they are going to use what type of pressure has to be utilized. In case of the uh, sorry, in case of the grinder, whatever is required, so there are certain reactive metals like titanium, zirconium, niobium, tantalum. So these are the grinding materials which are coated above the crushers and it will be continuously utilizing regarding the applications. So these applications are generally utilized with respect to the working conditions. So there is a fluid grinding mill or a jet mill. It is just for example I have taken. It is a basic principle. The basic principle is fluid energy mill is induced particle which collide against a high velocity fluid, which in turn fracture into fine particles. The pressurized fluid is introduced into a grinding zone through specially designed nozzles, which in turn converts applied pressure to kinetic energy. Here, the materials can also be powdered or introduced simultaneously into turbulence zone. What we can see is here we can create a powder and up to an average particle size of around 5 micrometer. Here the fluid used is about is either air having a pressure of about zero point 0.7 megapascals to 2 megapascals. The stream of 0.7 to 2 megapascal stream can be obtained with the inverse slope. Can obtain it, and the pressure whatever is going to be analyzed. So that pressure can be easily. So the other machining process or the powder production process that we are going to come across are machining, shorting, and grinding. In case of machining, chips from turning are crushed into powder. Magnesium, barium, silver, soldering, and dental alloys is going to be manufactured. And here, in case of shorting, a protective gas medium is going to be there. When a molten metal falls through the screen, it disintegrates and solidifies as a spherical particles. These particles get oxidized, and the particles are obtained depending upon the pore sizes of the screen. Like the particle size is depends on the pore size. Pore means the whole size of the screen. Temperature, whatever the temperature is used, which temperature is going to be uh, induced, the next is whatever the gas that is going to be used, frequency of vibration, metal produced by the metal which are produced like copper, brass, aluminium, zinc, tin, lead, nickel. So these are the materials is going to be manufactured with the help of shorting. Next is graining. Here the say it is same as shorting except the falling material through the sieve is collected in water. In case of shorting, it is collected in a protective gas medium on a screen, vibrator screen. But here in case of graining, it is collected or it is being placed onto a sieve which is collected on a water. Here, the powder of cadmium, bismuth, antimony are produced, especially whenever we require the different powders which are manufactured like cadmium, bismuth, antimony are used and that are to be used for manufacturing purpose. So these are the conditions how a powder production technology is going to be made. In case of physical method, we are having different physical methods to produce the powders like electrolytic deposition, which is used for producing copper, iron, zinc, tin, nickel, cadmium, silver, lead powders, and different metals having high purity, which are precipitated from the standard solution like your electrolytic solutions like copper powder. We are the solution which consists of copper sulfate and sulfuric acid and a crude copper anode. At anode, it will be having a pure uh, cathode, sorry, pure copper, and in case of cathode, it consists of the copper sulfate and sulfuric acid. In case of iron powder, anode is of low carbon steel and the cathode is of stainless steel. In case of magnesium, electrode position from purified magnesium and sulfate, sorry, purified magnesium sulfate electrolyte, which is insoluble, and lead anodes and stainless steel cathodes. So these are the conditions that has to be considered, especially in case of the working conditions. So this is a standard electrolytic procedure. So that is in case of a DC power supply is going to be given, that is anode and cathode is going to be placed, and the electrolytic bath. So that electrolytic bath is going to be considered for the deposition process, and this is the working how electrolytic deposition is going to be considered. So no need to explain how an electrolytic process is going to be work, how it is going to be considered. It states that a hard brittle layer of pure metal, which is subsequently milled to obtain the powder. So that is going to be placed on the cathode, and a soft sponge substance which is adherent easily will be scrubbed is going to be considered as a cathode. Sorry, not anode. A direct power, that is DC power supply, is going to be given for electrolytic operations. So that electrolytic operation is going to be considered with respect to electrolytic bath. So that consists of a medium, electrolytic medium. So that will convert the charges or materials from cathode to anode. So that is how the processing operation is going to be considered. So regarding the So regarding the chemical processing methods for product production is reduction of oxides, precipitation from solutions, thermal decomposition of compounds, hydride decomposition, thermite reactions, electrochemical methods. The next, in case of physical method of polarization, as water atomization, gas atomization, and special atomization methods. So these are the types that are going to be considered, especially for producing the powders. So this powder producing plays an important role for usage of your powder metallurgy, because with the help of this powder metallurgy technique only we can do most amount of production and as well as the working conditions or whatever the working that we are going to require, that will be done with the help of this powder. So the powder quality whatever we are going to get, it is having a good considerations, means then automatically the metallurgical or the casting process that we are going to use, it will be having a good considerations. So here one of the important parameters that has to be considered while discussing the powder is with respect to the most important parameter that has to be considered is the speed rotation of the drum, especially in case of ball mill. So the rotation of speed rotation of the drum has to be considered because here an optimum or a critical speed has to be adjusted for getting the maximum impact velocity. Here the critical speed is the speed above which the ball will centrifuge. That means when our ball starts centrifuging, so that is the critical speed. Very slow speed rotation will not carry the balls. That means the rotation whatever we are going to induce to that, so that at that time there will not be any, if the speed is having a less, means then the ball will not rotate it will roll back to the drum side itself. If very high speed, means the ball will not drop onto the your grinding material. So that's why a particular amount of speed has to be assigned. The rotation, which will be generally with respect to the speed of rotation, varies with inverse square root of the drum diameter. So that is with respect to the drum diameter, it is the speed is inverse of the inverse square root of the drum diameter. So that's why it is speed is equal to speed is inversely proportional to square root of the drum diameter. So that is what generally we are going to consider. If the drum diameter speed is different and speed is same, then you cannot get the actual amount of powder. So that is what one consideration. Here the material grinding media is and its size and density. The size and density of the medium, whatever we are going to use, it should be with respect to deformation and fracture resistance. So certainly for hard and brittle materials, large and dense media is going to be considered. Small bars are going to be used for the grinding purpose. The next is the rate of milling powder is with respect to the total space between the balls. So the milling powder, whatever we are going to use, so that will be having a particular size or the quantity that is to be within the space. The next is lubricants and surface active agents are generally used to nullify the welding forces. So that is why regarding the applications, we are going to decide what type of lubrications, what type of grinding materials, what type of milling materials has to be taken care, and how it has to be taken care is going to be taken out. And regarding the material operations, whatever we are going to consider, the mechanisms, whatever is going to be taken out, so that mechanism plays an important role, whether we will use an impact force or a shear force, or regarding the limitations, the rubbing action which causes powder contaminations, work hardening, sometimes the material may get hardened out, the quality of the powder, sometimes the material powder that we are going to manufacture or use will be having a less quality, the possibility error, and welding or amalgamation takes place. That means with respect to the heat generation, the material may get adhered, so it may lead to the failure. So these are all the operations that has to be considered, especially while considering the working conditions. And regarding the methods, the process mechanisms that will be utilized regarding the working condition, whether we have to go with respect to the actual requirement or whatever the process that is going to be considered, and how the material is going to be considered, what type of reduction process, whether it's a direct reduction process or an indirect reduction process, whether we have to go for the chemical methods. So in case of chemical method, already has to shared you the electrolysis process. So the next is in case of the mechanisms, what type of mechanism has to be considered, what are its limitations. So in case of limitation, sometimes there may be with respect to the costly reagents, sometimes whatever the reducing agents that we are going to use, there may be certain costly reagents are there. So that costly reagents will leads to the failure with respect to the working condition. So those are all the things has to be considered while discussing any of the powder metallurgy techniques. Powder metallurgy techniques. So in case of production of iron powder, we are going to use generally a direct reduction process. So here the magnesium oxide, the metal oxide is going to be mixed with the sponge cake, and the magnetic ore is then reacts with the carbon oxide, carbon monoxide, and that is going to be mixed. So these are all the working operations that is going to be considered, and finally you are going to get the iron powder or the ferrous powder is going to be taken care. In case of these are all the indirect methods or chemical methods. But in case of your physical methods, as I told you, automation, water automation, cryogenics, centrifugal automation, and the melting process, solidification process, those are all is going to be considered in case of your automation. In case of automation, the metal powders are generally utilized with respect to the three stages, especially in case of automation, that is melting, atomization, solidification, and cooling. In case of atomization and solidification cooling, the atomization is a important production methods, especially for metal powders. As I said initially, the melting in this stage, the important criteria is the melting distribution is required with respect to the crucible or the system that is going to be used. The second criterion is heating source with respect to the melting operations. The next is the last one is solidification and cooling. So here in case of solidification, the stages or the cooling rate is of control parameters. The dimensions of liquid droplets or solid particles are going to be considered. Here sometimes there will be an undercooling operation is going to be done. So that will affects the overall property and the microstructure of the particles. So that sometimes it may lead to the dimensional error, and that dimensional error will leads to leads to the powder quality reduction. So that powder quality reduction will may will affects in the final usage. So that's why Regarding the solidification, it plays an important role, especially while considering the working operations. Whenever the material has to be taken out, sometimes it may lead to the failure and sometimes it may lead to the working operations.